Who's online?
Factor by grouping is a factoring technique that is going to be useful when I have a quadratic whose leading coefficient is not equal to 1. Factoring by grouping is a useful factoring technique when I'm looking at quadratic expressions whose leading coefficient is not equal to 1. Or like you're going to see on some of your con practice as you're working through those assignments, you have a polynomial of 4 terms. So let's try one of these two. 4x squared plus 7x minus 15. That is a quadratic polynomial whose leading coefficient is what? 4, not 1. We've factored things like this, x squared plus 7x minus 15. Now there's a 4 out in front. I have a leading coefficient that's not 1 like this on the board. Factoring by grouping is going to be a nice tool. I'm looking for a pair of numbers that adds up to 7 and multiplies to whatever 4 times negative 15 is. What is 4 times negative 15? 4 times 15. 60. So let's think of a way to multiply and make negative 60 and add up to 7. I got negative 60 by taking negative 15 times 4, factors of negative 50, whose sum is 7. Anyone got a guess? 10 and 6. They got to add up to 7 though. They got to add up to 7.
I'm just
10 and 6.
12 and 5.
10 and 6. That was a good guess, but there's no way to add up to 7. We heard 12 and 5.
12 and 5. Wait.
Negative 12.
Equals 7.
Gotta have one of them negative though. How?
No, 12 and 5 don't work. Well, you know, it's 12 and 5. You just gotta find the right. You gotta.
Which one needs to be negative?
5 need to be. 5 need to have positive 12 and then negative.
Okay, why 5 negative?
Because we need to equal positive 7, and so 12 minus 5 is 7.
I knew 12 and 5 was going to do it because the difference is 7. You just have to figure out which one you need to make negative. Yep.
How long is the class?
Positive 7 when they add them together. 12 and negative 5 add to make positive 7. So it's comfortable.
You're a kindergarten. You should be paying.
Okay, so let's bring down our next line. 4x squared plus 12x minus 5x minus 15. I split the 7x into the 2 different numbers that we picked over here. Instead of 7x, 12x minus 5x. Is this still the same thing up above? If I simplified it, wouldn't I get back to the 7x I started with? Wrote my 3 terms, and I broke it up into 4 terms. In other words, I split the 7 into 2 pieces, 12 minus 5. Now I've got 4 terms to factor by grouping. Group them into pairs, the first 2 and the last 2. Now when I've got 4 terms written, group them into pairs of 2, the first set and the last. We're going to factor each of these 2 pairs by GCF. Let me say, Macy, what divides into 4x squared and 12x? What can I factor out of them? 4 and what else? What's the most number of x's I can divide from each? This has 2 x's, this has 1 x, so how many x's can I take away at most? 4x divides into 4x squared and 12x. What's going to go inside here? 4x times what is 4x squared?
X plus
4x times what makes 12x? 3.
so I'm just gonna go on left.
First pair we have factored, now let's come and do the second pair. What do you say, Stephen? Negative 5x minus 15 would factor into 1. What can I factor out of that?
5.
What about the negative 5? If I want to get the same positive x plus 3 factor that I had in the first pair, only way that's going to happen is if I take out the negative 5 as well. Not just 5, but negative. So negative 5 times what is negative 5x? Negative 5 times what makes negative 15? Plus 3. Notice how it's the same factor twice. One nice thing about factoring by grouping is you're going to get the same factor twice after you take out the GCF from each of the 2 pairs. When I write my final answer as two separate quantities, one of them is the x plus 3. The other is what's multiplying times x plus 3. What's multiplying times x plus 3 here? 4x. What's multiplying times x plus 3 here? Let's see if this multiplies back to what it needs to. 4x times x is 4x squared. 3 times 4x is 12x. Negative 5 times x is negative 5x. That makes 7x when I add them up. Negative 5 times 3 is negative 15. I multiply it back together. Basically, just undo the factoring that I started with. 2. Try to put more on this.
It's huge. You didn't realize that? I didn't know. I didn't see it.
Appreciation.
Progress.
All right, on that handout, I had some practice on factoring some polynomials of 4 terms. I pulled up that practice that I showed you off the Google Doc there, actually.
You filled out.
Okay, let's try a couple on this handout.
I wasn't really confused. Gotta help me.
Okay, so how many terms do you see, Brooke?
C4.
Group them into pairs. That's why it's called factoring by grouping. You group them into pairs of 2. Put little brackets around them. Let's factor one pair at a time. The first pair and the second pair. How about this first pair, Parker? 12a cubed minus 9a squared. What's the GCF? What can I factor on both? 3a squared. 3 divides into 9 and 12. They each have at least an a squared I can factor out. Both. Perfect. We're going to bring down 1. 4a minus 3. The whole point of factoring by grouping is to get the same 4a minus 3 when I factor the next pair, the 4a minus 3. Is anything divided into 4a minus 3 other than 1? No. So all we have to do is take out a 1. 4a minus 3. If nothing else divides into them. If they're both prime, then take out a 1. That's all we can do. Let's make our 2 quantities. One of them is obviously 4a minus 3. The other is what's multiplying times 4a minus 3. In the first pair, what was multiplying times 4a minus 3? 3a squared. And the second set.
I remember doing that.
Oh, we did this, yes.
Yeah, we did this last
First semester.
I don't.
That's why we're doing this here at the end of the year, because you're going to need it next year. We did this last semester. First semester.
You can't do that.
Does it multiply back together to make what it should? 3a squared times 4a. 12a cubed. 3a squared times negative 3. Negative 9a squared. 1 times 4a and 1 times negative 3 makes those last 2 terms.
Okay.
10 minutes. Do the next one. Do 2 on your own, please. Let's see if you got the next one. 2p cubed plus 5p squared, 6p and 15.
Yeah.
I can't get that out of my head.
How me finish up this first. How about that? We have some more talking about 5 minutes, all right? More. Good. Keep factoring.
Keep factoring. I did.
You substitute.
This is my future job. No, it's too.
So with this one.
Nope, that's a scrap. We'll do the exact opposite. We'll multiply that together. Factor x squared plus x minus 6.
You're gonna get it too. Promise if I did it right. Because I feel like I did it
How can you always factor
right.
what?
That one reading.
Multiply that together.
So make sure I got it right.
2p on 5 squared.
Yeah.
God.
Multiply that together. That's the big start.
3 and
Okay, cool.
We got it. We got it.
Would this just be one? That's the same.
Yeah. And then they can't release them.
So it's gonna be plus 1. Hey, let's keep factoring. Group them into pairs of 2. What do you say? What can factor from the first pair? 1. 1, but I can actually take out some p's too, right?
P squared.
P squared. P squared. P squared. Leaving me 2p plus 5. Factor from the second set. 6p plus 15 have what common factor?
That one can do 3s.
3's. 6 and 15 both divisible by 3. Do we get the same 2p plus 5? Let's write our final answer. Does it matter the order you write them now? I was going to put 2p plus 5 here. It doesn't really matter.
Yeah.
Does multiplication matter when we talk about order? No.
And so I think
But whatever order you want.
I'll get back.
Oh, same.
A times B is the same thing as B times A. Order doesn't matter. So if you want to put the 2p plus 5 second, you put the p squared plus 3 first. Either way is the same. What are your thoughts here?
See the difference.
Factoring by grouping? Feel like we got it?
Sure.
Okay.
The 5 difference.